Welcome back to our series on applied regression analysis. I'm Mark Ledbetter. This is lecture video 46. We are in chapter 13, part 2. So far in this chapter, we're dealing with ANACOVA, or the analysis of covariance, and we've talked about the adjustment problem, okay, how we want to make an adjustment between, let's say in the last example, I think it was blood pressure and age. So age was the covariant, and we wanted the average blood pressure difference between males and females, which was our major study factor, controlling for the age of each. Okay, and so we also talked about the assumption of parallelism that is required. So it's an assumption, but we need to check it. So you need to check this before proceeding with ANACOVA. And we started looking at an example of, we looked at an example of several groups and several covariants instead of just one. Okay, so we're going to look at some examples in this video. So we're going to look at example 13.2, and this was data that was collected to study the effect of rapid cultural change on the health status. So specifically, a goal was to determine whether blood pressure was associated with the prestige in the modern part of this culture, okay, relative to the traditional culture. So here's how the researchers categorize prestige. So group one was modern prestige was much higher than traditional prestige. So this is their opinion. So when you're answering this survey, you're going to say, yeah, I'm in group one or I'm in group two. That the modern prestige is not much higher than the traditional prestige. And three, traditional prestige is much higher than modern prestige. So we have three groups, so we need two indicator or dummy variables. Okay, so the data was collected from 550 males. So this tells us that N is equal to 550. The variables are diastolic blood pressure, age, and the Quetelet index, which is a measure of body size. So an analysis of covariance model is given by Y, which is the diastolic blood pressure, beta naught plus beta 1 age plus beta 2 Quet plus beta 3 Z1 plus beta 4 Z2. So, so Z1, if you're in group J, it's a 1 for ZJ. So Z1 equals 1 if in group 1, Z2 equals 1 if in group 2, Z1 equals Z2 equals 0 if in group 3. Okay, so to test for parallelism, we look at this, and we would need that beta 5, 6, 7, and 8 would have to be 0. Okay, so now in this model, okay, so in this model, where we have beta naught, beta 1 age, beta 2 Quet, beta 3 Z1, beta 4 Z2, and then we need to add the interaction. So Z1 age, Z2 age, Z1 Quet, Z2 Quet, okay? So if 5, 6, 7, and 8 are all 0, then we can say that we have parallel lines, right? If you remember from our previous discussion of dummy variables in Chapter 12 and some of the previous examples we've done here in Chapter 13. So the multiple partial F-test was not rejected, and we looked at this last time. So the use, or we didn't look at this last time, but so it says we looked at this earlier at some point, and let's see, so it doesn't tell us when we looked at it, but we looked at this earlier, apparently, and the multiple partial F-test was not rejected. So the use of ANACOVA model is justified. Whoops, did the wrong thing. So it is justified. Okay, so we do not reject H naught. Okay. So from the regression fitting, we can have that the mean, unfortunately we couldn't get this bar to go all the way across everything, but this bar is for the whole thing. So the average of diastolic blood pressure 1 adjusted would be beta naught plus beta 3 plus beta 1 plus beta 2. Okay, so this is 1. This is where Z1 equals 1. So if we look back at our model here, the model we're going to use, if Z1 is 1, then we have beta 3, a 1, then Z2 has to be 0. Okay? So we're left with this beta 3 that we're adding to beta naught to change the intercept. And so that's what we have here. And then we just have beta 1 age and beta 2 q it. So that's if Z1 is 1. And then if Z2 equals 1, then we look in our model and we see that beta 4 would be times 1 and beta 3 would be times 0. So we end up with beta 0 and beta 4. Okay? And then still beta 1 age, beta 2 q it. And then for Z3, or this is Z3 means Z1 equals Z2 equals 0. And so we're left with just beta naught plus beta 1 hat plus beta 2 hat q it. Okay. So now, using the data, the adjusted mean scores can be found this way. So we have the unadjusted and we have the adjusted. So this is in the group 1, the prestige group 1. This is group 2. This is group 3. And so we had 87 for N1, 383 in group 2, and only 80 in group 3. And remember, group 1 said that modern prestige was much more higher than traditional. This says that it was somewhat higher than traditional, and this says that traditional is higher than modern. Okay? And so we can find 71.68 is the average in the unadjusted average, and the adjusted average would be 72.07. Then 68.16 becomes lower here. So this one becomes higher, this one becomes lower, and this one becomes higher by a little bit. And when we did the p-test, we do the f-test for this, the p-value turns out to be between 0.001 and 0.005, so it is significant. So we use the model, it says 13.9 with 2 and 545 degrees of freedom. So 13.9, I believe, is this model here, although I don't have model numbers listed, unfortunately. So that's the model. And so 545, where did we get this? Remember, this is N minus P minus K. So N was 550. P was our number of covariance or study factors. We had not covariance, study factors. We had 3 of these groups. So there's 3 of them, but we only do 2 dummy variables. But it still counts as 3 variables. And then our covariance are age and q it. So these are age and q it score. Okay. So testing for the equality of the adjusted mean scores would be equivalent to testing that H naught B3 equals B4 equals 0. And the p-value implies that there is a significant difference among the prestige groups. But the clinical standpoint of view, the difference may not be significant enough. Okay, so from the clinical standpoint of view, this difference may not be significant enough. What are we talking about? So let's look at the differences between this. We're talking about diastolic blood pressure, and the unadjusted is 71.68. So you might round up to 72. You would round up to 72. And then if you're measuring this, you'd round down to 72. And this one you'd round to 68, and this one we'd round to 68 because we report to 1 point. So practically speaking, there's no difference here, even though it's statistically significant. Okay, and this would be 69, and this would be 69. But see, so if you round to 0 decimal places or to whole numbers, there's no difference in any of these. So the statistical standpoint of view is that there's a significant difference. But from a practical standpoint of view, there is no practical difference in this. So practical point of view. Okay? All right. So now we have a different problem. A company wants to compare 3 different point-of-sale promotions for its snack foods. And so here are the 3 promotions. Buy 2 items, get a third free. Mail-in rebate for $1 with any $2 purchase. Buy reduced price multi-packs of each snack food. So the company's interested in the average increase in sales volume due to the promotions. 15, N equals 15. Grocery stores were selected in a targeted market, and each store was randomly assigned one of the promotion types. During the month-long run of the promotions, so it's only 1 month. Now, I would tell you that you need to do this across the different seasons if you want to see the difference, but you could also say that, well, it's better to see, instead of having to account for the difference in seasons, just keep it within the same season. So both arguments are valid arguments there. The company collected data on increase in sales volume, which is Y, in hundreds of units at each store, and it's to be gauged against the average monthly sales volume, which is X, prior to the promotions. Okay, so Z1 is going to equal 1 if promotion type 1, 0 otherwise. Z2 if promotion type 2 or 0 otherwise. So Z1 equals Z2 equals 0 means Z3, which is the reduced price multi-packs. Okay, the data's here. We've figured out the overall average is 33.6, okay, for X, which is our covariant, and Z, our promotion, which is our major factor, study factor, is promotion, which is replaced by 2 nominal variables. Okay, so here's the output with the interaction terms here. Okay, so we have these 2 interaction terms, and we have, with the interaction, we have the type 1 SS, so variables added in order. Remember, you can add those to get the total. Now, we want to state an ANACOVA regression model for comparing the 3 promotion types and controlling for the average pre-promotion monthly sales. That's X. So here's how we do that. So that is Y equals beta naught plus beta 1X plus beta 2 Z1 plus beta 3 Z2 plus epsilon. Note that there are no interactions because we can't use interactions if we want to know the difference. Remember, we're not supposed to use this method if there is interactions. So we first have to check whether or not there is an interaction, whether or not it's appropriate to use the model in A. So here's our test. Beta 4 equals beta 5 equals 0 against either beta 4 or beta 5 not equal to 0 in the model with both interactions, with the interactions or with both interactions. Okay. So we look back at our model with, let's see, okay, it has the model here. So this model here, so beta 4 is 0, that's here, beta 5 is 0, that would be here, that would get rid of the interaction terms, and so that's what we want to test. And so our multiple partial F test is F of xz1, xz2 given xz1, z2, okay? So here we have the SS of xz1, xz2 given xz1 and z2. So we're going to have 5. There's 5 total variables here, and we're testing it against 3. So the difference, the additional variables are 2. Okay, and then we're going to take the SSE of all 5 in the full model divided by the degrees of freedom, n minus k minus 1, right? Okay, so that's where we get that. And there are 5 total variables, as we see here. And then so n minus k minus 1. Okay, and we can calculate this as SSR with the full model. Let me zoom in. Of the full model minus SSR of the 3 variables with the reduced model divided by 2 in the numerator, and then the SSE of all 5 divided by 9. So we can just pick up the 19.35 here. Let's see where we get these numbers. So the 19.35 are, let's see, 53? Should have been 53. Yeah, 532. 19.532. I said it wrong. Is picked up right here. So the MSE with 9 degrees of freedom, that's the error. Okay? And so let's see how we get the other numbers. Sorry about the scrolling. Don't have much choice. So we got 219.943 minus 183.66. So the difference here is 219.943 minus 183.666 equals 36. So this value is 36.277. So again, they're assuming that you have two ANOVA tables, and what they're doing is they're subtracting the SSR. Oh, and here it is down here. I didn't notice that we do have this one. So we could subtract, this is the second model, and this is the first model. And so we could take the 219.943 minus the 183.66577. Okay, so that's how we can get that value. Okay, and let's come back down here. Okay, and so don't forget to divide this by 2. We get 0.929, and they give an alternate calculation here where we could take the 2.414 and the 33.864 from the type 1 SS. So let's look at that. So that was, I think, the 61.2 and the 6.85. Is that right? No, this is 2.414 plus 33.864. Let's see where we're if we see those values on here. Oh yes, here they are. It is the type 1. I was looking at the wrong 2. So this is a type 1 SS here for the interaction terms. Okay? So we add that together. That's going to be the difference by adding those two interaction terms at once, and divide that by 2, and then divide that by the MSE of the full model. Okay? So let's see what we get. So in both cases, we get the same answer, as we should. We have 2 and 9 degrees of freedom. 2 in the numerator, 9 in the denominator. And the p-value turns out to be 0.25. So at alpha equals 0.05 or alpha equals 0.1, do not reject H naught. And we can conclude that the ANACOVA model in part A is appropriate, that we can leave out the interaction terms. So we want to use ANACOVA to determine the adjusted mean increase in sales volume for the 3 promotions and test whether they differ significantly from one another. And it says, note, mean pre-promotional average sales volume equals this. And we calculated that. I showed you the calculated earlier. And the unadjusted mean increase in sales volume was 13.4 for promotion 1, 12.4 for promotions 2, and 17.6 for promotion 3. Okay, so they're giving you these values so that we can use them as needed. Okay. So here are the sales increase. These are the adjusted means. These are the unadjusted means. So they gave us these unadjusted means here. Okay. And so Y1 bar adjusted is going to be beta naught plus beta 2 hats plus beta 1 x bar. And beta 1 x bar is 33.66666, 33 2/3. Okay, so we plug that in. We plug in our estimates of these, and we get these from the model without the interaction. So let's go look at the model without the interaction, and our parameter estimates are here. Okay, so beta naught hat is there. Beta 1 hat is here, beta 2 hat, and beta 3 hat. Okay, and so they've plugged these in here. Remember that beta 2 hat was negative, and beta 1 hat was positive. Okay, and so then Y bar 2 adjusted, remember that beta 2 will be 0. So here beta 3 hat, or beta 3 is not beta 3 is 0, Z is 0. So we have here we have z1 is 1, z2 equals 0. And in this one we have, in this model, we have z1 equals 0 and z2 equals 1. Okay? And so we end up with 14.97, we end up with 11.549 here, and for y bar 3, this is where z1 equals z2 equals 0. So all that we have is beta naught and beta 1 x bar. And so that gives us the highest one, 16.83. Okay, so we've got the adjusted means and we have the unadjusted means. And so this is nearly 2, 1.9 increase. This is minus 2.57 in a decrease, and this is a plus 0.77, I think. No. Let's see. So it's over 1. No, it's 0.77. That'd be 15, 16. Yeah. So a plus 0.77 there. Okay. So we need to test that beta 2 and beta 3 are 0 versus that either one of them are not in this model without the interaction. So our test statistic is a multiple partial f test, z1 and z2 given not x1. And so here we can do SS of z1, z2 given x over the MSE with all three. Okay. And so here we have 3 minus 1, so that's going to be 2, the difference of 2 here, so 2, and that's 2. And then we have n minus k minus 1, so 15 minus 3 minus 1. And remember there's 3 sales promotions, so there's 3, these are sales promotions. All right. And then the minus 1. Okay, so then we have, so we could use SS of z1 given x1 plus SS of z2 given x and z1, all divided by 2, and SSE of the 3 divided by 11. So let's look and see where we get the 61.212 and the 6.852 from. So we get those right here from the type 1 SS. So we get those values right here. This is for Z1 and Z2. Okay? And we pull the 19.27887 from here, where we just have the full model with 3 variables. And so that gives us, if I can find it again, here we go, 19.279. And I've written out a different way to do this. You're welcome to take a look, but I think what we did was much easier than this. And so we get an F value of 1.765 with 2 and 11 degrees of freedom. We find, by using our F table, that the p-value is between 0.10 and 0.25. It's a good idea for you to look these up. Look up this 1.765 and look up in the table with 0.1 in the upper tail and 0.25 in the upper tail and see that this value falls between those two F values. At alpha equals 0.05, we do not reject the null hypothesis, and we conclude that the adjusted means do not significantly differ. Okay, so there's really no significant effect or difference in the mean, in these means, based on the promotion, adjusted for the promotion or unadjusted. Okay, all right. So actually, I wrote these positives in the wrong direction. These are the unadjusted means. These are the adjusted means. So that means I should put the, for prior, unadjusted prior. So this is negative, this one's positive, and this one's negative, because going in this direction, going in the other direction. Okay, all right. Okay, so that's it for this chapter. Please don't forget to scan your lecture notes by midnight, the date listed in the course calendar. If you have questions, come to virtual office hours. If you need an answer before you can make it to virtual office hours, then email me a picture of the problem and a picture of your work, and then I can help you by email. Please take care of yourself and stay safe. We hope to see you next time.